Alright, so this problem says the same heat transfer into identical masses of different substances produce different temperature changes. That's because their specific heats are different. Okay? Calculate the final temperature when 1 kilocalorie of heat transfers into 1 kg of the following, originally at 20 degrees Celsius. Water, concrete, steel, and mercury. We'll just do A and B, and you guys will know the rest, okay? So, A, Q is mass times delta, C times M times delta T, okay? So, what are we trying to calculate? Changes in temperature. Okay. So, delta T is Q over Cm. Okay. So let's do this for water. Okay, so part A is for water. So delta T for water would be Q is 1 kilocalories, 10 to the power 3 calories, and C, the specific heat. We'll do this problem in calories. Calorie per we'll go. Okay, we'll do it calorie per gram per degree Celsius times mass, which is 1 kg. I'm messing up on the units. 10 to the power of 3 grams. Okay. Alright, so the rise in temperature for water would be 1 degree Celsius. Okay. The calorie cancels, the grams cancel, and the Celsius will come to the top. Yep.
Why don't we use joules instead of calories?
Just because I remember this. If I want joules, then I would have to ask Ben what the values for C is. You could do that. You can do any units. Alright, you want to do it in joules? Let's do it in joules. So 1 kilocalorie, 10 to the power 3 calories, and then you have to convert that to joules, and that's 1.486 joules per calorie divided by, what is the specific heat for water? 4,186 joules per kg per degree Celsius, and then 1 kg. And this will work out to 1 degree Celsius, exactly. Okay. All right, let's do part B. Let me add a page below. So part B. So what we're going to do is we're going to dump 1 kilocalorie of heat on 1 kg of concrete now. So what you did was, in this part, what you did was you dumped 1 kilocalorie of heat into 1 kg of water. And this was the rise in temperature. You're going to do the same thing, 1 kilocalorie of heat into 1 kg of concrete. Okay. So you see, higher the specific heat, lower the rise in temperature. All this, everything else being the same, higher the specific heat, lower the rise in temperature. Okay. So again, delta T is Q Cm. All right, this time we'll do it in joules, because for concrete, okay, 10 to the power 3 calories and 4.186 joules per calorie. What's the specific heat for?
840 joules per kilogram Celsius.
814?
840, not 14, 40.
Okay. So this will work out too. All right. So what we are seeing is okay. So this is how breezes rise. Okay. So we're seeing you have the same amount of sunlight falling on concrete and water. The temperature of water rose by 1 degree Celsius. The temperature of concrete rose by 5 degrees Celsius. Now this air on top of the concrete will get warmer. This will rise. It will leave behind a low pressure. Here there's a high pressure and you get a breeze in that direction. Okay. So they say, so here's the thing, differential heating is what causes all weather. Okay. If you raise the temperature of everything by the same amount, you wouldn't get breezes. If the earth were flat, you wouldn't have global weather and stuff like that. Yeah. All right.